In this video, we're going to take a look at organic families and functional groups. This should say functional groups, not function groups. So let's examine these two organic compounds over here. This is an organic compound called propane, and you'll learn why later. And this over here is an organic compound called propanol. You'll see they look very similar in terms of the number of carbons they contain, 3 carbons, 3 carbons. But what's quite apparent about the difference between them is that propanol contains this OH, whereas propane doesn't. This OH is an example of what we call a functional group. So we said that organic compounds are carbon-hydrogen-based compounds. There's different classes of organic compounds that can exist. There's different groups of organic compounds that can exist. And those different groups of organic compounds that exist, they are called organic families. Now, what decides what organic family you're part of is a specific chemical group. And that specific chemical group that decides which organic family you're part of is called the functional group. And the example of a functional group is this OH group over here, which is called a hydroxyl functional group. And the idea is that the different organic families have different functional groups, and because they have different functional groups, they'll have different physical properties and chemical properties, like different types of reactivity. So the different functional groups, they will help to determine a few things about the molecule. They'll determine how soluble that molecule might be. So for example, if you remember from the first unit, propane would be not very soluble in water because it's nonpolar. But then if we had an OH group and get propanol would be more soluble in water because we added a polar group to it. So it determines solubility in different substances. It affects the functional groups, affects melting points, boiling points. So as you would know, this over here would not have a very high boiling point because all it has is LDF. But this over here would probably have a higher boiling point because it has LDF, but because of the OH group, it also has some hydrogen bonding. So it has that as well. And then the functional groups also determine reactivity. So this molecule here will undergo different reactions than this molecule here. And that's primarily because of the OH group. The OH group can do different types of reactions if you have it and if you don't have it. So because there's many different functional groups that exist, there'll be many different types of organic families. And the way organic chemistry is organized at the high school level is that you spend the unit exploring the different organic families. So you'll look at organic families with OH, which are alcohols. You'll look at organic families with COOH, which are carboxylic acids, and you'll learn the properties, how they react, and also their applications. So we're going to take a quick look at a table of functional groups. You do need to become familiar with them and know them. Our first step really is being able to use the table of functional groups and being able to identify functional groups within molecules. So let's take a look at this table over here. This is our functional group table. And so the way it's organized is you have the class over here. So the family, in other words, type of organic compounds that exist. You have a structural formula. A structural formula is just like a general formula for what these compounds might look like. So let's go to our alcohol one over here. So you'll see general formula is R and then OH. So what this means is there's a carbon chain. R represents a carbon chain of some sort. Doesn't really matter the length. It could be a one carbon chain, 2 carbon chains, 3 carbons, doesn't matter. So for example, this over here would be the R group. And then next to the R group, which is the carbon chain, you have your functional group, which is the OH in this situation. And so if you contain the OH functional group, you're part of the alcohol family. The name of the OH functional group is called hydroxyl, and it's an OH bonded to a carbon chain. And the example that you can see here is when you have the OH, the molecule is called propanol. You'll notice that if you don't have any functional groups at all, you're just pure carbon-hydrogen, you're called an alkane, hydrocarbon, specifically an alkane. If you have only carbon-hydrogen, but double bonds, you're still a hydrocarbon, not an alkane this time, you're an alkene. And so that is technically considered a functional group, your carbon-carbon double bonds. If you have carbon-hydrogen only, and then you have a triple bond in there, so that functional group triple bond, that makes you an alkyne. You're still a hydrocarbon. Hydrocarbon basically means you're only hydrogen and carbon, but with the triple bond, you're called an alkyne. And then you'll notice that some families that are hydrocarbons still are called aromatic, and those families would essentially contain this special ring here called a benzene ring. And so right now this doesn't mean much to you, but each point over here is actually a carbon, and there's H's you don't see. But what's interesting is that this alternating double bond pattern here, that makes this specific ring, this 6-carbon ring with alternating double bonds, benzene. And so if you contain benzene, you're part of the aromatic hydrocarbon family. And this is just an example of a molecule that would contain that functional group. Some organic families are called haloalkanes or alkyl halides, and the functional group they have is they have a halogen atom bonded to the carbon chain. So you can see the 3-carbon chain here, and here's the halogen atom there. That makes this chloropropane. So each functional or each family is named. You'll see their general formula and structural formula. You'll see the name of their functional group and the description of their functional group, along with an example of a name for a molecule, which the picture you can find in the next column over. So if you have ethers, the general formula or structural formula is an O with 2 carbon chains on either side. They don't have to be the same carbon chain. They could be different lengths. They could be the same length. Doesn't really matter. But that's called an alkoxy functional group, and that makes your molecule an ether. And so you can see an ether over here. This here is called an aldehyde. And so an aldehyde is RCHO, which is carbon chain. And then this is the functional group here, the RC double bond O with the H next to it. So this part here is a functional group, and that's called our carbonyl or carbonyl functional group, C double bond at the end of a molecule. Okay. And so here's an example of an aldehyde right here. Now, ketones are very similar. You have RCOR. Notice they look similar to aldehydes, but the difference is that here's our carbon chain, here's our carbon double bond O. Instead of having an H next to that, you have another carbon chain that's attached to it. So it's like the actual functional group is a C double bond O in reality. That's the actual functional group. I shouldn't have circled the H there. I should have been more specific. Is the C double bond O, and then if there's an H here, then that makes it an aldehyde. But if there's an R here, that makes that a ketone. And so here you can see C double bond O is somewhere in the middle of the chain rather than being at the end of a chain. And so that makes this a ketone instead. So it's still a carbonyl group. It's still the same functional group, but the location of the functional group actually gives you a different class. And so if for the aldehyde, it was called propanal instead of propanol. And for the ketone, it was called propanone. So notice how the functional group makes you part of a specific family. And if you're part of a specific family, your name changes a little bit. You have a different ending to your name to let the chemist know that you're part of that family. And so we're going to learn all those naming rules by after we've studied the functional groups in a bit of detail. Carboxylic acids, they are RCOOH, which essentially means carbon chain. And then you have the C double bond O, OH. And so you'll notice that this is almost like a blend between the carbonyl group and the hydroxyl group of the alcohol that we saw earlier. Together, these two make what's called a carboxyl group rather than carbonyl group. So it's carbonyl and hydroxyl group together. So it should be hydroxyl here. And so here we have a carboxylic acid, and you can see that carboxyl group here. That's called the propanoic acid in this situation. They're not all called propanoic acid. It depends on the chain length. So if I had another carbon here, there'd be a different name. Esters are quite interesting. This is an ester, RCOOR. So you have a carbon double bond O, and then an O over here, and then you have a carbon chain here and a carbon chain here. So you have this little group here, that's your ester group. So it's basically like a carboxyl group, except notice that instead of an H at the end here, next to your O, you have another carbon chain there. So this would be an example of an ester. We have this group here with carbon chains on either side. So you do have to pay close attention to detail because a lot of these functional groups do look very similar, right? You might think, oh, isn't this a ketone? Well, no, look, the ketone only has C double bond O. There's no embedded O within the chain like the ester has. Okay, so there's some small differences, and those small differences have a huge impact on what the molecule actually is. So you have to be very careful with that. Here we can see an amine, RNH2. And so you have a carbon chain, and then you have your N. Okay, it could be NH2, it could be N with other things attached to it, but you have your N over here. Okay, and that's called an amino group, nitrogen with one or more carbon groups attached to it. And we can see that situation over here. This is called propanamine, this molecule here. Maybe you might be able to guess what the propan part refers to, or the propan in all of these molecules. What does that mean? Look at what they all have in common. And you might figure it out. And then here we have the amide, which is RCONH2. And so we have our carbon chain. And notice that it looks similar to an amine. There's an N there, but you have a C double bond O connected to that N. And so this is your amide group over here. And the functional group name for that is called a carboxamide. So it's a carbonyl group bonded to a nitrogen. And so you can see that in this situation here. You might think, oh, isn't this an amine? Well, no. This part here is an amino group, but once you have it connected to the C double bond O there, that makes this an amide group. So don't call it amino, call it an amide group. And so that was a quick overview of the functional groups. There's actually another video that you'll watch that goes into a bit more depth with this and goes over some practice problems with identifying them. The video can be found in this handout over here. So you can click on that video lesson there to watch that. It goes over primarily what I just went over here, but with a bit more depth and a bit more slowly, so you can get a better sense of what functional groups are. So you should be familiar with what functional groups are. You should be able to use this table to identify functional groups within molecules and start being able to recognize functional groups even without this table, as that's it'll save you a lot of time when you're trying to do some problems in organic chemistry. So what we're going to do is in our next video, we're going to do some practice problems. We're going to try to identify functional groups in a variety of different molecules. For now, be sure to understand what functional groups are, go over this table over here and this quick little video lesson over here to get a bit more depth. And then afterwards, we'll come back and try the practice problems on the final page.